Good afternoon. It's September 16th, and this is episode 16 of Rob Explains, your daily podcast discussing and explaining cool, random, and interesting things. I'm Rob. Thanks for joining me. Continuing with our discussion about human anatomy and human evolution, I wanted to kind of bring up something that I had heard years and years ago, but that never really made sense to me. And I did just a little looking around, and it confirmed the very thing that I thought. You may have heard over the last decade that redheads are going extinct, that because such a small percent of the population, less than 2%, are actually redheads, that this will eventually just stop appearing in the human genome. Maybe more starkly, that people with red hair and very pale skin, including freckles, that makes up less than 1% of the population. And going even further, redheads with pale skin and blue eyes make up a sliver, less than 1% of the population. And because of this, it is likely that they'll just die out and we will never have redheads again. Now, the context of the story is, of course, that gingers are a thing of the past. But the fact remains that is not true. As I've said in previous episodes, DNA is a blueprint for a human. And once you have something in that blueprint, it can always appear. In an earlier episode, I talked about how there are native populations all over the world that will have a blonde-haired, blue-eyed child in them. And in some populations that are more blonde and pale skin, they can have dark-skinned, brown-eyed, black-haired children. Because those genes are always in the genome. And because we are intermixing as a society, as an entire genome, Homo sapiens sapien, then any of those recessive genes that may not appear as often can still rear their heads randomly and by chance almost. Red hair is a recessive gene. It is excessively recessive because it is recessive generally only in Caucasians. Now note, I said Caucasians and not Caucasoids. We are not biologically different, but Caucasians as a subset of human beings generally will show the recessive genes for red hair more often. And the same for blue eyes. But I'm reminded of the mugshot-turned model from a few years ago, who was a black gentleman in the United States that had crystal gray blue eyes. No surgery, no contacts. He was born with those eyes. Because the way his parents' genome lined up, the recessive gene just showed itself. Everyone, every single human being, every cell in their body has the blueprint to perform any of these operations. It's just whether or not they show. I could probably do a longer episode about dominant versus recessive genes and how that comes out, but as a quick refresher, remember from biology class back in 9th, 10th, 11th grade in high school, what we would call the P-pod chart. And that was 4 squares where there was 2 capital P's and 2 lowercase p's. And when you match things up, the boxes generally were capital P, and then one of each in 2 of the boxes in different places, and then 2 lowercase in the bottom right. Well, it's less likely that you get 2 recessive genes that show themselves on a person. When they do, you have red hair and blue eyes. Now, there are certain populations, specifically in this case, those in the Irish island, that have a high percentage of people with red hair and pale skin. They have 10 to 30% of their population displaying this recessive gene. But let's say that because Ireland is no longer isolated, that number goes down and it falls closer to 0. It will not matter. At some point, that recessive gene will display itself, and we don't know where. Keeping in mind that hair color and hair texture and hair type are completely separate genes. So you may have someone in sub-Saharan Africa with typically African hair that just happens to be red. We see it now with blonde hair in some populations. Blonde hair is, of course, also a recessive gene. So although they may get rarer and rarer as the intermingling of the different races and their genomes mean that the dominant genes take over, they will never truly be eliminated because the blueprint is always there. Now, as a side note, there are a few exceptions to that. The genome, although we have unlocked it and studied it, can be a mystery. if there is some sort of biological damage, well, perhaps that genome would be damaged and we would never see a redhead again. If there was a massive human extinction event, that may eliminate redheads too, because the recessive gene isn't within every living human at one time. The blueprint is there, yes, but it may not have been passed down. At one point, early humans got down to 15 breeding pairs, meaning that there were essentially 30 early humans on the entire planet. And all of us come from those 15 couples. Our genome is limited in its entirety to just what genes that were expressed in those 15 couples. Similarly, if there was another extinction event that cut out a large swath of the human population, some of those genes may take generations, hundreds of millions of years, to show themselves again. Also, although it's less important to modern humans, if there was some sort of biological advantage to having red hair, we may see more people with red hair coming out. And if there was a distinct biological disadvantage to red hair, we may see it naturally die out. Although it's hard to imagine a situation where that would be the case. One, anyway, that didn't involve also having an extinction event. So don't fret, gingers. The future of red hair is not on you, and having brown-haired children doesn't mean you've let down all others like you. Everyone has the genes for red hair, and there will always be redheads with us. And even if it stops showing itself as naturally as often, there's always dye, right? Thank you for joining me for this episode of Rob Explains. Look for new episodes daily wherever you listen to podcasts, and subscribe to make sure you don't miss an episode. Do you have a subject you'd like me to cover, or just looking for more Rob Explains? Find us online on all social media at Rob Explains. Got a comment, question, or query? Or did I get something wrong and you want to correct me? Shoot me an email, rob@robexplains.com, or you can leave a comment down below. I'll check those right after the show goes live. And you can send me a message, anchor.fm/RobExplains/message. And in the form of a voicemail, I can actually include it in a future episode. Once again, thank you for joining me. Until next time, this is Rob. Take care of yourselves and each other. Have a great day.